to do. I'm going to repeat. Wonderful, guys. So the plan is I'm going to repeat myself because a few people will watch it later. I am going to do a lot of problems from 2.3. Why do I say a lot? Because I will not start 2.4. And last class, yesterday, we talked about this and that. We talked about a lot of ideas. We're going to use them. So I'm going to kind of redefine them a little bit or explain to you from scratch why things work the way they do. So it'll be a little repetition of yesterday's lesson, but we'll do some problems. So again, well, let's go ahead and do some from here. Let's wrap up this cluster, okay? So I don't remember the numbers that I did, but I remember I did something with sine theta, cosine theta. So let's do one with tangent. Let's do 55. Okay, let's do 55. It's similar. And when you see something like this, it should trigger trig identities. And I'll show you what trig identities are. We discussed them yesterday. I'm going to tell you again what they are. There are three of them. And again, if you ever need help with any of the homework problems, all you have to do is email me and I will incorporate the solutions in the next video. Be specific, mention the course and also the number, ideally a screenshot. All right, guys, let's see what we can do here. Oh, I want to like this. Okay. Now, these are called the trig identities. Let me show you. And there are three of them. I have to find it. Now, bear with me a little bit. Put them in this pile. Not this one. Or I can easily type it, but oh, right here. Awesome, guys. Okay, so this is, we call it trig identities. Okay, these are the trig identities. Okay, a couple of things you want to make sure you understand. Okay, all right. Yesterday, we proved that I'm going to briefly, I'm not going to show you the proof again. We just had our equation x squared plus y squared is equal to 1. That's the equation of a unit circle. We replace x with sine and y, x is cosine theta. We replace x with cosine and y with sine, and we got the first one. We divided both sides by cosine, and we got the second one. We divided both sides by sine, we got the third one. So you're going to use these, all right? Now, if you have tan theta that's given, I'm going to leave them here and you want to make sure this is in your notes, okay? When you take the exam, unless you want to memorize it, and you should, it's not going to hurt. So I have tan theta. I'm not going to use this one or this one. I'm going to use this one. And the second one will allow me to find secant theta. Okay. Now, because of the square root, I am going to run into plus minus. All right. What will tell me, what will allow me to decide which sign is correct? This part. All right. So that's the basic structure of these problems. They're roughly the same. So I know tan theta and I know the second formula, and I'm going to see what I can do. I'm just going to worry about the second one, just so that you know. So I will write it tan square theta plus 1 is equal to secant square theta. All right, this is something I know. All right. Okay, so instead of tan, I am going to write 3/4 squared. Where is the square coming from? Because it's tan squared. It's not just tan. Your question gives you just tan, but you are really looking for tan squared because that's what your formula contains. Tan squared plus 1 is equal to secant square theta. Fine. That looks good enough. And most of us, not that it's that important, we tend to write what we're looking for on the left-hand side. It's just convenient. That's how it's done. It's a custom. It's not a requirement. All right. So here I'm going to say, of course, you can use your calculator. 3 squared is 9 divided by 4 squared is 16 plus 1. Okay. Now, if you replace 61 with 16 over 16, you're going to add it. You know how to add fractions. You're going to get this. I'm going to check and I'm going to double check just to make sure I didn't mess up. Okay. That sounds about right. Now, you really want to know what secant theta is. In order to get the value of secant theta, you will take square root of both sides. I'm going to do it here. I'm going to drag it down in a second. Okay, guys? So when I take the square root of 25 over 16, I will take the square root of the numerator, which is 5 divided by 16. Now, I am going to put a plus minus sign now. Okay? I'm going to put a plus minus sign because whenever you take square root, it could be, and we know secant theta can be plus or minus. So I don't know for sure what the right one is, but I will put both. Now I need a little extra room. I hope it's not too small for you guys to read. If it is, you just tell me. Okay. Now I am going to go back, bring my unit circle, just a unit circle. I don't want to redraw it. All right. The question says sine theta is negative. Remember, guys, sine theta is the y coordinate of the point on the unit circle. If sine theta is negative, it has to be either in this quadrant or this quadrant. That's for sure. Because in the third and the fourth quadrant, sine theta is negative. This is very important. Don't ignore it. All right. Tan theta clearly is positive. You know it's 3/4, so you know it is positive. It's not negative 3/4. So in among or between these two quadrants, here, both sine and cosine are negative, so tan will be positive. Okay, once again, in this quadrant, the third quadrant, sine is negative, cosine is negative, and to find tan, you divide sine by cosine. Negative divided by negative is positive. So it has to be in the third quadrant. It cannot be here because in this quadrant, sine is negative, true, but cosine is positive, and that would make tan negative. So my conclusion is, so I did a lot of work. Here. It's not obvious. My conclusion is this point, my terminal point, or whatever you want to call it, has to be in the third quadrant. Now, I'll be happy to repeat what I just said. And it is being recorded, but that's not the point. The point is you just have to tell me. Can you explain that again? What did you do? So I know my theta, I don't care. I don't know where it is, but I know it's in the third quadrant. Okay. In the third quadrant, secant is the reciprocal of cosine, right? And in the third quadrant, cosine is negative, and therefore secant has to be negative. I'm going to go erase my plus minus and stick a minus sign here. Now let me try it once again. All right, guys. If sine is negative, theta has to be in the third or the fourth quadrant. But since tan is positive and
Why
tan
is
is
sine negative? I'm sorry for
sure,
interrupting.
no problem. Let's try it. Okay. Now Good. I'm glad you asked. Let's go, unless I made a mistake, but I don't think I did. Okay. Tell me, how far are you with me? Are you okay? Do you see that your angle will be in the third quadrant? Do you see that?
Yes, I understand why it's in the third quadrant, I think. I
Mm-hmm.
just got as far as working out the problem, but when we got to doing our prediction, I kind of got lost.
Okay, let me say the whole thing again. All right. And tell me where I'm losing you. Okay, would you agree when sine theta is negative? Sine theta is the x coordinate. X coordinate is negative here and here. Would you accept that?
Right, but I thought sine was we was looking for y.
Yeah, y, this is the y-axis, isn't it?
Okay, okay.
Okay. So if you're here, it's going to be negative. 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 Are you with me?
Right.
Good. All right. Moving on. And you're just representing the class. Okay. I'm not picking on you. Since you're outgoing and you're asking me a question, I'm going to use your questions to help everyone else. All right. Now, um, I am in this quadrant or this quadrant. Now, in this quadrant, x coordinate is negative and the y quadrant, the y value is also negative. And what is tan? Tan is, let's write it down. Let's write it down. Tan is, I'm going to write it down on the side, but that's why you also want to kind of, it helps to kind of memorize them. Sine theta over cosine theta. Okay. Would you agree if I said tan is equal to sine over cosine?
Right.
Okay. If sine is negative, cosine is negative, tan will be what? Positive, right?
Positive, right?
So since tan is positive, my cosine has to be negative.
Okay, so now I understand why
Very
sine
good.
and cosine is.
Very good. Now that I know cosine is negative, cosine and secant are buddy-buddy. By buddy-buddy, I mean they're reciprocal. So if cosine is negative, secant is the reciprocal of cosine. That has to be negative. Does that answer your question?
Yes, that answers my question.
Very good. And don't be shy. I appreciate your talking to me. It helps everyone. It helps me. Otherwise, I feel like I'm talking to myself. All right, good. If I'm actually now I'm talking to everybody. If you want to interject, which is not a problem, you can always interfere and say, I don't get that. Can you repeat it? Not a problem. All right, so guys, it's a lot of work. I know I rattled away all those things, and here let me explain one tiny thing uh, for you guys. Since you guys are taking the course online, you have access to all the formulas. That's good. Okay, but you also want to know some of the formulas that will help you think. Otherwise, you'll have to just flip through your pages. Okay, you'll feel a little lost. So remember some of the basic. I'm talking to everybody. Remember some of the basic formulas, and then the ugly ones, of course, you can look it up. All right. Now that I know secant theta is negative 5 over 16, not anything else, I am in good shape. Now, if you would let me, as far as I know, I'm being recorded. Yes, I need the room, so I'm gonna get rid of this. I don't need this. I don't need this. I don't need this. And I don't need this. I'm gonna clean it out. I'm gonna write it neatly. All right. Now, I know secant, and I'm supposed to find everything else. I know tan. Well, if I know secant, let's quickly find cosine because they are reciprocals. I sometimes say buddy, but I actually mean they're reciprocals. So you want to quickly find cosine. And that's going to be 16. No, yeah. Let me double check, guys. I may have messed up I made a tiny error. Actually, let me go back. Okay, I made a tiny error. Let's fix it. Okay, when you take the square root of 16 is 4. Looked a little bad. So it's actually going to be 4, okay? Let's go back and fix it. Square root of 16 is 4. So it's going to be 5 over 4, and we explained why it should be negative. So having said that, I am going to delete this. I'm going to delete this. And don't worry, I'm going to check my answer, okay? If I mess up, I'll fix it. All right. Now, if this is secant, I'm going to go ahead and say this is cosine. All right. Now, guys, if I know cosine and tangent, I can always find sine. Why? Because tangent is sine over cosine. So let's rewrite that. So this is a bit more challenging than the ones we did. So I'm going to write tan theta is equal to sine theta divided by cosine theta. All right, now take a look. I know the value of tan theta. I know the value of cosine theta. I do not know the value of sine theta. So I'm going to do some replacement and I'm going to do some work with fractions. Instead of tan theta, I'm going to write 3 over 4. Why? Because that's given. Instead of cosine theta, I can write negative 4 over 5. Why? Because I calculated that right above. Now, I am gonna, it's called cross multiplication, guys. You can multiply this fraction with this fraction. I'm gonna do it by hand on the side, and I'm gonna write my final answer here. This is what's being done, okay? 3/4 times negative 4 over 5. And I'm going to put the negative sign here for convenience, okay? So this will turn out to be the 4 and 4 will cancel. You'll have a -1. You'll get negative 3 over 5. That's what you're going to get. So this turns out to be, when you multiply this, it's really like saying multiplying both sides by -4 by 5. And if you multiply -4 by 5 here, trust me, you're going to get negative 3/5. So that tells me I'm actually doing not too bad. By that I mean, it's not as bad as we think, actually. And -3/5. All right, so now that I have sine, guys, I have sine. I am gonna, if you don't mind, I'm gonna right now find, oh, let's do it here. I am gonna find cosecant right away. And that's gonna be the reciprocal of sine, and that's gonna be negative 5 over 3. So I am almost done. Almost done, guys. I have secant, cosine. I have sine and cosecant. I need cotangent. Cotangent is very easy. Cotangent is reciprocal of tangent. And let's do it here. Cotangent is reciprocal of tangent. Now, before I let you ask me questions, if you don't mind, I'm going to quickly check my answer. It's very easy to mess up because I'm kind of talking. So I'm going to check the answer, then I'll take your questions. And if you want to go, if you want me to go over something else, I'll be happy to do that. All right. How did you do that? Those are all valid questions, but let me double check. This is number 55, 2.3. The -5 over 4 is secant. Let me grab this. All right, so what did we get? We got secant as -5 over 4, cosine as -4 over 5, and cosecant right here, -5 over 3, sine, where it's sine, -3 over 5, and cotangent. We are good. So I'm going to get rid of this. Okay, before you ask me questions, guys, let me tell you one more thing. These questions can be solved in multiple ways, but this is one way. But let's see if I can explain anything further. I'm going to pause there a little bit. Okay, guys? Don't be shy. All right, then, not a problem. We'll take one more from this cluster, okay? One more, maybe the last one from this cluster. You guys can pick one if you want to. If you think something looks ugly to you, pick one. If you let me, I will pick 56 because it's one of the inequalities we didn't use, but it's very similar to what we did. If you want to pick something else, you tell me. All right, so again, I'm going to do it carefully. I'll try to do this one. Okay, again, you understand these slides are from the previous one. They don't apply, but let's work on it. Okay, if I know cotangent, I am going to use the third one to find cosecant. Now, somebody could say, okay, if cotangent is 4/3, tangent will be 3/4, and I know tangent, I'm going to use the second one. Please be my guest. That'll be totally fine. But I am going to just say, I'm going to use this one, the third. It's called trig identities. Let me write it down, okay? Trig identities. Trig identities are basically the ones you're going to use to work on problems from this section, and you just have three of them. The first one is very easy, sine squared theta plus cosine squared theta is +1. And the other two are a little hard to keep straight, but you have access to your formulas, right? It shouldn't be too bad. All right, guys, so I'm going to do some work here, okay? And then I'm going to delete my work because I need room. I'm going to write cotangent square theta +1 is equal to cosecant square theta. Fine. Now, a couple of things, guys. Sometimes students want us to show everything, which is fine, but I'm just going to tell you when we write too many things, it happens to me and it happens to some of my students. We tend to make a lot of mistakes. So one thing you can do, you can save a little bit of time too. You can say cotangent square theta will be 4 square over 3 square. So you're going to get 4 square is 16 over 3 square is 9. The more you write, the likelihood of making a mistake goes up. And so you don't want to write everything. It's just a suggestion. So hopefully now you understand how cotangent square theta is 16 over 9, 4 square over 3 square. All I have to do is add the left-hand side, and I can do it like this. I'm going to show you this one instead of 1. I'm going to write 9 over 9. And now that I have the same denominator, 9 plus 16 is 25. I can write 25 over 9. Now, all okay so far, hopefully. I came here and I want to find the square root of both sides now. And what do I get? I get cosecant square theta is equal to plus minus what is square root of 25? 5. What's square root of 9? 3. Much better. You're less likely to make a mistake. Remember last time I left 16? So I'm just trying to avoid such an error. Now, I have to carefully analyze and convince you the right sign. I don't know it yet. So cosecant is, cosine is negative. The question says so. Where is cosine negative? Cosine is the x-coordinate. X-coordinate is negative here and here. But cotangent is simply cosine over sine. And since cotangent is positive, both cosine and sine are positive. Sorry, either both are positive or both are negative. So now you're asking, so this allows me to narrow it down to these two quadrants, okay? But this tells me if cosine is negative, in order for cotangent to be positive, sine has to be negative. So back again, I am here. I'm going to pause there a little bit to see if you follow what I did. I'm back to exactly in the third quadrant like before. I'm going to go back and replace it with negative. And this is cosecant, that's cosecant square. All right. Now it's not, let's pause there a little bit because I need room and I'm going to delete these first three lines. So cosecant is negative 5/3. I can easily find a bunch of things. I can certainly find sine. Cosecant and sine are reciprocals. So I'm just going to use one here, the room here. Sine theta is negative 3/5. Now, if you don't mind, guys, I'm going to delete this. Of course, it has been recorded, hopefully. So it stays here. All right. Of course, from cotangent, I can find tangent. Might as well do that. Doesn't hurt. So I know cotangent and tangent are reciprocals of one another. So I'm going to say tan theta must be equal to 3/4. Now, like before, I know tan, I know sine, I can find cosine. So I'm going to do that. I am going to claim, and as we know, tan theta is equal to sine theta over cosine theta. And what do I know? I know tan theta. I'm going to do it here. Tan theta is 3/4. 3/4. And let me see. Yeah, sine is fine. Sine is negative 3/5. We'll be fine. We'll squeeze that in. Negative 3/5. If it kicks me out, I'll come back and start here. Don't panic. Negative 3/5. I need to find cosine theta. Okay, so it's called cross multiplication. If you have a function like this, if you have a relationship or equation like this, and you're looking for cosine, you can actually swap these two and swap these two. So I'm going to swap these two. Okay, there's a 1 here. Okay, it's based on cross multiplication. So you can swap the top and bottom and swap the top and bottom. So those are acceptable steps called cross multiplication. And your teacher taught you something a little different. Apply it. Your goal is to find the value of cosine theta. And I'm going to claim cosine theta is basically this. I'm going to put it here. Need to go up. Okay, when you have two fractions like this, all right, if the two tops can be canceled, or if you want to do flip and multiply, that's totally fine. Remember, flip and multiply. You take the top fraction, leave it alone, and you take the bottom fraction and you flip it and you multiply. Okay. Now you can see the 3 and minus 3 will cancel. Minus sign will be left. The answer will be negative 4/5. Negative 4/5. Now, doesn't look too bad to me yet. All right. So if I have this, a little bit of room would help, but I'm going to leave it here in case you guys ask me a question, but I need a little more room here. I'm going to leave it here. Now, if this is cosine, I am going to quickly go ahead and find a reciprocal of cosine, which is secant. I'm going to drag it down. You'll have everything. Secant theta is negative 5/4. All right, let me go ahead and check the answers, check my answers, and then we are going to discuss number 56. Okay, 10 is 3/4, that's obvious. Let's see here. Minus 5/4 is secant. Minus 5, that sounds good. And let's find cosecant. Minus 5/3 is cosecant. Minus 5. So we're good. If cosecant is this, of course, sine is going to be this. If secant is this, of course, cosine is going to be this. So we got it all right. Let's pause there a little bit, guys. Let's pause here a little bit. There's a lot going on, okay? And that's why I'm slowing down. That's why I kind of spent a little extra time in 2.2. And trig is like that, guys. It's a lot in one section. So guys, I have this slide here. Let's jump out of this session before it kicks us out. And I'm going to quickly come back and continue working on this section. All right, guys, see you soon.